mama, I'm sure all the hand and I just around. Action speaks louder than words, and I'm a man of great experience. I know you got another man, but I can love you better than him. Take my hand, don't be afraid, I'm gonna prove every word I say. I'm advertising love for free, so you can place your hands on me. Won't they come along and down by the dozen? That ain't nothing but kissing love. Hey, little thing, let me light your candle coals, and mama, I'm sure all the hand and I just around. Yeah, all the hand now. Oh, baby. Baby, here I am, a man on your scene. I can give you what you want, but you got to come home with me. I got some good old
I was gonna
love,
come in and sing till class started, but you're already playing
when
music.
I get through throwing on you, you gotta come running back for more. Once I run along and down by the dozen, I ain't nothing but just old love. Hey, little thing, let me light your candle coals, and mama, I'm sure all the hand and I gets around. Hard, hard the hand and I. Oh yeah, yeah, yeah. Once I run along and down by the dozen, that ain't nothing but tender loving. Hey, little babe, let me light your candle coals, and mama, I'm sure all the hand and I gets around. Yeah, go all the hand and I. Oh yeah, baby, a good love hand, baby, oh, good love hand.
Everybody. Let's see. How we doing on audio? We're good? Yo. Hello.
Yeah, I can hear you.
Awesome. Thank you. Okay. Thank you, Jay. So, welcome. Next week's Thanksgiving. I think we all need a break. I know I do. I presume you do. Well, by break, I mean not just a break, but also a chance to get caught up on things. So, which is also a form of break, right? I think that's fair. Let me see. Kind of a quick update on schedule stuff. So we are on module 9 today. We're going to talk about the final project, the larger program, the bigger project thing is the topic of today. It's also kind of loosely about problem solving and stepwise refinement, a little more about that. And then when we come back from the break, we'll have 3 modules left, and they are short ones. They're small ones. The IO, the trap routines, and the stack, and those easily fit within those 4 days. And we can still do if there's a big enough group that wants to do help sections on any particular things, let me know, and we can try to just get some of those on the docket. The key would be, that if you have, watched the lectures, done the reading, done your part of that. I don't want to duplicate lectures when the lecture's just sitting there on YouTube. I think it makes sense. But where it's kind of a small group that's really kind of question driven, right? Where maybe it's not entirely clear to you from the lectures and or the book. Cool. One other thing I just want to say, kind of for the record, it's this is one of those things where, I don't know if the people who need to hear it are here. But there have been increasingly what I kind of think of as, we try to be super available. We have been under shorthanded because of losing Talmadge, and we're still at this point trying to get through the HR thing and get us a new TA to supplement the hours. But so that's been a little bit of a stressor. But I think we've still, Vlad and Zach and I have still tried to be, as responsive as we physically can be. But what I've noticed is that there's inquiries to us, and I think more to the TAs than to me, but an inquiry that kind of takes the form of almost like the TA is the kind of personal cheat sheet. And what I want to just kind of make what I mean by that is like, hey, I'm having a trouble with this particular, question, right? Well, what we're not going to do is just go, oh yeah, question, module, whatever, question 7. Yeah, the answer is 17. And, okay, because the goal is not to get the answer. That's actually an indirect or secondary goal. The real goal is to learn, right, and to acquire the skills. That's the actual goal. And so I just want to remind you, again, if you're watching, maybe you're not even, one of the ones that I'm really talking about, but we will always try to walk you through. We're going to kind of go, okay, yeah, let's talk about it. We want to know, what do you currently understand already? Where's the lacking? Where's the disconnect? Let's help you bridge that gap. And we'll do it by walking through the question with you and trying to see, and assess where you're at. There have been a handful of exchanges with the TAs where I've been really disappointed in the students for sort of becoming, a little bit impatient and pissy with the TA because the TA is not just telling them the answer to the question, but is in fact trying to make a sincere effort to see where they're at and to guide them. And, a little bit, and I understand, there's pressure and, whatever, you get impatience. I'd just like you to consider what it is we're trying to do. And if at any time you feel like things are not being handled appropriately, obviously, or even optimally, come talk to me. That's not a problem at all. All right. So that's my little mini speech. Okay. What we're talking about today is the final project, the large program. I'm pulling it up and I'm putting it on the big screen over here. And then I'm going to blow it up for you. And is that readable? Is that visibility okay? I can make it bigger. What say you? Pros, cons?
Yeah, it's pretty readable.
It's readable. Should I make
Maybe
it
a
just
little bit bigger if you
a little
can.
bigger? Hang on a second. Let's do that.
Yeah, that looks good.
All right. Awesome. Thanks for the feedback on that. So here it is. I want to are you ready for my fear of God speech? I don't know. Dr. K, fear of God speech, number 5. Actually, one of the big number 1 fear of God speech for me is this project. It's let me see. It's typically it's always a bit more involved than anything you've done so far. It's a reiteration. It's a repeat of the same principles that you've been doing in the little homework questions. Okay. When I did this the first time, I think I've actually done this twice, like kind of from scratch. The first time that I did it, I think it took me 6 hours in one mighty binge. I literally kicked into the thing about 1 a.m. and just went through the night. And at 7 a.m. it was done working, and probably butt ugly as far as the code is concerned. But it was working, and there were things that I was not satisfied about it and whatever, but it worked. And so, and that's about as quick as really, any student has ever done it. And it's not like, you're like, well, you're Santa, you've got, you've got the doctorate and all the experience. Yeah, it doesn't make me a professional LC3 programmer, spending all day every day, so that it was just like, I still had to kind of grind through and remember, and you know what I mean? This is not, programming in LC3 assembly is not something I do like every day of, professionally. And I've never done it like, it's not a real computer. So there's not really professional LC3 programmers. So just understand that, there are students that have done it faster than I did it, who are whatever, smarter, probably just smarter, or just whatever, you know what I mean? More aptitude, or that's a world they live in more than I do even. But the vast majority are going to be more than that. And, but I would say, you got to be ready to spend, I don't even know, right? I mean, it might be 20 hours. I don't know. Could be 10, could be 20, could be 40. I mean, the problem with programming is that, there have been studies to try to assess the variability between productivity or skill or speed of various programmers. And if we lined up everybody in the class, the ratio, the difference between the best, let's just say the fastest LC3 programmer in the class and the average might be 5-to-1. And to the worst, let's call it the worst, by worst I mean slowest, functional. There's another tail off where it's like you're not getting it, and you'd never get it done, with the current skill set you possess. So ignore, tail that off. Just deal with like, you can get it done. How long is it going to take you? That might be 10-to-1, right? And the problem is, just understand, there's no way to normalize that. You can't be like, well, Dr. K, we're only supposed to spend this much time, for out of class, for every hour in class, blah, blah, blah. We can have another conversation about that, because that's usually misquoted and misapplied, okay? That's a descriptive metric, meaning it describes a phenomenon. It's not prescriptive in the sense that this is what must be, or proscriptive in the sense that outside of that it must not be. You know what I mean? And the problem is with programming, with our field, if everybody was to sit down and write an essay for an English class, and I gave you 2 hours to write the essay, and everybody submitted it, you might all get a passing grade, and there's going to be a variability. But you could all get it done by just writing words and, vomiting onto your keyboard and turning it in. Computer science, you don't have that luxury of turning in crap. I mean, in the sense that your code might be crap, but if it doesn't work, it doesn't work, and you're not done yet. That's the problem. There's a bit of a binary switch on a lot of assignments in CS major. You know what I'm trying to say, right? If it doesn't work, you're not done yet. And in a lot of programs, it's like, until it works, you're at a 0 still, and then finally it works and you jump to, whatever the rubric is. So just trying to say that I'm trying to prepare you that if you're one of the people that this is going to take a long time for, and you're a slower programmer, you got to budget more time to do it. That doesn't make the class wrong, or me wrong, or the program wrong, or computer science wrong. There is an innate variability in the speed with which people program, and there's no way to take all of that into account. So you try to find a reasonable middle ground, and some people are just going to just smoke it, and some people are going to take forever. And, you can't optimize to either end without messing somebody up. Does that make sense? So just understand where you're at, and understand that as you get into the computer science major, this is part of the drill. There's the other thing that is impossible to actually measure is time to find a bug, right? I have had bugs professionally, bugs that took me, I remember there was one, it wasn't my bug, but in order to isolate it and prove to the developer that it was in fact a bug and what the nature of the bug was, it took me 100 hours of professional, which was basically 2 very long weeks to actually isolate this bug. So I'm just, right? Sometimes it'll reveal itself very quickly and you're like, oh, I see my problem. And you can get better at it over time as well. But sometimes bugs are just very elusive, and, So again, just understand that's part of this field that you can't predict, when you're going to be done with stuff. Therefore, you start early and get it done, and then you've got room to spare on the back end. You pick up a day or two. You were budgeting. You didn't know, right? So anyway, does that make sense? When I was an undergrad at Iowa, I just remember being a new undergrad and being in an assembly class actually there. And there was one of the new Star Wars movies was coming out. This was 82, 83. So whatever it was, The Empire Strikes Back. It was the original release, the theatrical release, because I'm old. And I remember my buddies on like a Saturday night were piling out to go to see this movie. And I had a program that was due on Tuesday. And I didn't go because it's like, I literally don't know how long this is going to take me. And I was actually done, that night by like midnight or whatever. And I'm like, yeah, I probably could have gone, but you know what I mean? It was a commitment to say, I don't know how long this is going to take. So I better just budget to doing it. You know what I mean? And then do the other stuff later because I just don't know. So just be ready and you got to take that seriously. If you wait until the day it's due, you're kind of screwed. Probably screwed. It's been done, but I don't recommend it. Okay? If you wait till the day before it's due, probably screwed. And this thing is due on the last day of the semester, the last day of class. So it does show a December date 10. That is a firm, all these December 10, finishing the homework and having that stuff done is all. That's concrete. Okay? We will be able to do more retakes on module exams during the finals week. So that's what we'll do with finals week is do exam retakes. If that's takes or retakes, but the homework has to be done. Okay. Also, last thing, let me see. I do have, Mike, I got a little bit of a hot mic on you, I think. So just a heads up on that. But the other thing I was going to say is just remember that the homework has to be done by the last day of the semester, by the last day of class. The homework has to be done reasonably. If you submit, Mary Had a Little Lamb as your homework on the last day of class, we won't accept it and you won't be able to take that exam. It actually has to be reasonable. The homework has to reflect a reasonable attempt. You know what I mean? And demonstrate some understanding. All right. I hope all that's good. I'm just trying to, give you a little bit of that sauce. All right. Let's talk about the large program, okay? And what I'm going to do is just try to walk you through it. I've got my scratch pad right here, my markers, multicolored Sharpies, and we'll try to walk through this. Eventually, I'll have a whiteboard with a separate camera where I can step to the whiteboard while we're doing this remote thing. But for now, this is kind of what I got. I do have the whiteboard over there hidden behind that curtain. But the problem is, what the problem is. I'm not configured up yet to take advantage of all that. All right, so let's kind of go through what this thing is. Oh, yeah. The fear of God speech, number 5. The big fear speech is you can... This is worth what? 14%, 15%, thereabouts. It's just 100. It's just 100 points. Let me see. It's either 14 or 15% of the overall grade. 16%. It's either 16%. So I was wrong on that. Okay, it is 16%. What that means is that you can do all the homework and then do all the exams, smoke all the exams because you can retake them, and pull 100% on all that stuff, not do this program, and get a B. Okay? Now, here's the thing that you have to understand. Versions of different things, you're going to find them floating around or there's somebody else's stuff. Here's the fear speech. I've said this before. If we detect that you're cheating on this project, there's literally no incentive to cheat on the homework. Really, literally, you cheat on the homework, I don't even know what your motivation would be. But this thing is one where there's points outstanding, and you're kind of on your own. Things I want you to understand. I have in my possession every submission of this project for the last 2 years. Okay? There aren't really, on balance, there aren't that many. They are somewhat notable. When you write code by yourself uniquely, it looks different. Okay? It's like a fingerprint, and not like really, really subtle. I mean, it's a very obvious fingerprint. The other thing to just understand is that one of the things that I do as a consultant is code reviews for companies in litigation cases. They might be like patent litigation, but a lot of times it's sort of like copyright cases where there's an assertion of misappropriation either of source code or of trade secrets. And the job is to, go sit and, look at a repository with 10 million lines of code and then ask yourself, did any of this come from any of that? And if so, how and why and where? And then document it and then testify in court or, submit declarations as an expert, that it's my expert opinion that this or that. Okay, I'm just trying to say, looking at code to understand where the code came from is one of the things I do. And there are a bunch of methods that I employ in my consulting, profession. And then people pay me the grandes to do that. So the ability to look at this code, typically these run in the neighborhood of 500 instructions, is probably an average size. Looking at 500 assembly instructions, it's remarkably easy to see copying. I also have copies of every instance of this program that I've ever seen solved online anywhere. Okay? And this is the fear of God speech. If you have borrowed the code from somebody else, and even if you've massaged it to try to make it look different, then I'm Liam Neeson all of a sudden. I will find you. And if I detect that, then you flunk the entire class. You get to this level, you get to this point, and then thank you. Exactly, that's me. Okay, all of a sudden, and then you fail the class, and you're reported to the honors, whatever that office is called, right? So it's better to take your B than to risk cheating, on this thing. Really, truly, it's better to take your B minus or your C plus or your C than to risk the high risk that hits, right? So just kind of be forewarned about that. And besides the fact that you can always, if you need to, you do a retake, you come back, it's still me, it's still the module system, you come on back, and now you do the first 4 modules cold, so you show up next semester, you take the first 4 module exams in the first week. And then, you know what I mean? You can set yourself up if you need to. So it's way better to come back next semester than to risk trying to go find some other, someone who's done it and borrow that. Okay? Is that good? Fear? Is the fear surging? Well, and it really shouldn't be surging because you're like, I'm not afraid at all about that because it's not anything I was going to do. So I'm not afraid, but it does make me afraid in behalf of others who might make that decision. All right? Everybody cool with that? Right on.
Yeah, it works.
All right. And the really amazing thing that I like about the organization of the class, the way I've done this thing, is this is really the only instance in the entire semester that even has any temptation to try to lack integrity and to cheat. You know what I mean? Everything else, it really is, it's all, even the exams, right? Look, take it, learn the material, take it again, It's set up for your advantage, okay? L'chaim. Okay, let's do this thing. Let's talk about the program itself, then I'll talk about some design things and we'll hit some requirements. I've got my big screen over here And my print straight ahead on a little monitor is not very big, so I'm going to apologize for looking off camera over here. But all right, so an assembler. We talked about what an assembler is, right? It takes your assembly programs and it turns those into machine language. One of the things it has to do is read and look for the opcodes that are in the, what do we want to call these? The textual version, like add, ADD, and AND, right? And, jump, JMP. There's characters, and it has to convert that into binary opcodes, right? And it knows pretty straight up that add is 0001, and is 0101, right? It's a direct mapping. This is one of the easiest parts of an assembler, all right? So what we're really doing in this exercise is we're building the very, very first sort of rudimentary thing in, to build an assembler, and we're doing it in assembly language, in LC3 assembly, okay? So here's what it's going to do. It outputs a message to the screen that prompts the user to type in an LC3 assembly language instruction. And then the user, types the thing and presses enter, hits the return key. All right. Now, what should be obvious, and we'll talk about it, what should be obvious is you've got to be able to have a string, and you've got to be able to output that string. All right. We've talked about the various trap instructions. You can look at those. We haven't gone deep into it, but you can look at those in the documentation, which is on Canvas, right? I've got all those little cheat sheets for the trap codes and the other stuff on Canvas, as well as they're in your book as well. Okay, so you've got to have the ability for the user to type stuff in, and for you to dump a string out to the screen. You're going to do those with trap instructions, all right? And you do actually have everything you need to know at this point to do this, but not without probably looking it up, looking at the cheat sheet for the trap instructions and what have you. Okay, that's the first step. If the instruction that they typed was a legal LC3 assembly language instruction, then you just display the opcode. You don't have to be fancy about it. So if I typed ADD, enter, then you would spit out 0001. Okay?
Hey, Dr. K.
Yeah.
Say hypothetically, basically you were done with a project, and say hypothetically that you actually did it where it's like they input character by character, says input a character, press enter. Would that be acceptable as well?
No, you'd have to modify that probably.
All right.
If you actually had it done. But if you had it all the way done, then probably that's not going to be that hard to change.
Yeah, no, it won't. Thanks.
Yeah. All right. All right. Yeah. So they need to be able to type the name, the name of the instruction, ADD, and they might type something that's incorrect, right? Like, instead of typing and, they type N, A-N, or Andy, A-N-D-Y. These are not correct, right? And so if it's not a legal LC3, then you need to just spit out some kind of error message, right? That's it. And then you go back to the top. After you display the output, whatever it is, you go back to the top, kind of reinitialize your system, get everything kind of cleared out, and then do it again. All right? And then if they type quit, then you stop. Your program halts after they type quit. And not until. Okay? I've now got a bunch of notes. Okay? I'm going to go through the notes. And then I want to talk about ways to think about the design. Okay? There is not a lot of style points. The code itself, there's not style points for the code. It can be butt ugly. There's not even style points for the way it looks, the input-output. I'd recommend you try to make it clean. Try to make your code also clean, which makes it easier to understand and maintain.
Super quick question.
Yeah.
You probably already mentioned this and I just missed it, but we're writing this in assembly, not raw machine?
You are writing this in assembly language, yeah.
Okay.
Once you get off the chapter that's about machine code, once you get to the module that's about assembly language, what is that? Module 6, 7?
Both 6 and 7 have you writing stuff in machine code.
Okay. Well, once you touch assembly, then we try to, pivot to assembly language. Unless it's explicitly asking you about, machine language.
We're not sadistic.
Yeah, right, exactly. The machine, the traipsing through machine language, when we're rolling through machine language, we're doing that as an exercise for learning. Then when we want to do any sizable programming, it's got to be assembly language, because the machine language just becomes so cumbersome, crazy cumbersome. Okay, let's hit the notes, and then we can kind of answer any additional questions. And I'm going to we'll do a little bit of design discussion. First note: your program needs to treat it as case insensitive. It means we don't care what case they're typing in. If they do it uppercase, lowercase, or a mixture, we don't care, right? So all of these, right? Capital A, little d, big D, these would all be valid, okay? Now, let me see. As the user types an instruction, you need to echo their typed characters. Now, what happens is when you're just inputting, the input of a character and the fact that character appears on the screen, those are actually two different things, right? So if they can type, this is why you can type your password but nothing appears, sometimes, and the cursor never even moves. You press enter and it goes. When you have a character that somebody types and then it appears on the screen as they type it, we call that echoing. Okay, you echo their input. So what has to happen is they enter a character. You then, take that character, read it in, and spit that character back out to the monitor. They enter the next character, you spit out that character, et cetera, until they press the enter key, and that's when you stop that loop. Okay, that's when you stop looping. All right. So you have to echo the input. This one, there's a couple ways of doing this assignment, right? You're trying to find out, did they type and not Andy, and not an, and not right? You can do that a couple of different ways. You can process the characters as they enter them. For example, you could say, if they typed Z, right? The first letter was a Z. You already know that's not valid, right? You don't even care whatever else they say. You already know it's not valid, right? So you can process, as they enter and move through your logic, or you can just let them enter everything until they press the enter key, and you're just shoving it all away in memory, just putting it all into memory. And then you've got a string, and you literally are creating a string in memory, like a dot string Z makes a string. You're making your own string by putting each character they enter, put it in the next location, and when they're finally done and they press enter, you put a 0. Now you have a null terminated string. The thing is, and this is kind of key, these are just how you do that is just a design decision, okay? I'm partial to enter it all in. It just feels, kind of clean that way. And yes, Mike, we're doing this for all the opcodes. That's right. And there's a caveat down there about the branch instruction, which has a lot of variance. But here's the thing. If you know that they're wrong, they type Z, and then they're like Zorg rules, and they're typing a bunch of weird stuff, right? Even though you knew on the first character that they were wrong, you still have to wait until they press enter before you give them their failure message, okay, their error message, right? That's just kind of a little bit of usability. If you start to type Z and the message just comes, it's startling. They need to be able to type what they typed and press enter, then they get the message that says, nope, that wasn't correct, even though you might have known about it, okay? And we can talk about design, ways to do that, right? Can the user use the backspace? Ignore the backspace. It's nothing but trouble. It's nothing but a pain in the butt ski, okay? Let me back up, David. So, Mike, I did answer yours, right? All the opcodes. Is there a file format that assembly files use? And the answer is it's just Notepad or whatever. It's just a text editor. It needs to be a text editor. If you're in a word processor and you do a copy and paste, you're bringing all that other formatting crap with it. Okay? If you take from so I just say it's just a text file. It's just a text file. Okay? Now, there are some, like, I don't even know, right? Maybe Eclipse or maybe some of these kinds of tools might even have, like, formatting and helpful stuff, like, for the LC3 assembler. That's possible, but I don't know. But at the end of the day, it really is just a text file, okay? And so the literal answer, Chris, to your question, is there a file format? Yes. Basically, it's .text. And you just change that to .asm for assembly, .asm, but it's just a text file. That's it. Backspace, yeah, David, yeah. I've seen it attempted. You know, I mean, and if you want to do that, I'd say, I mean, there is a backspace key. You know, and you can interpret that and do different things. If you wanted to do that, I'd probably give you some extra credit for it. Okay, I'm going to come back to that note. Let me do this one. For the branch instruction, you only have to handle BR. The truth is, right, there's BR, BRN, BRZ, BRP, right? It's BRNZ, BRZP, BRNP, BRNZP. You don't need to handle all those variants. That would just it's just arbitrarily constraining it to say only BR. Oh, this is what I was just talking about. Write your program in a text editor. Save as you go. And you can do this one of two ways. One is you can actually copy that and then text it into the simulator, or you can actually take and drag the file itself into the simulator. Okay, which we shall show you. Let me drag this guy over here, and if I go to the assembler here, right, you can paste your assembly file below, or you can drop a file on this box. Literally just grab something, drag it over into this box, and all the text will show up. All right? Leave that there in case you want to play around. Yeah, and I mentioned it puts a bunch of non-ASCII crapola into the file, okay? And then also, where that really messes you over is when you're doing something like, if you have like smart quotes enabled, okay, those are different characters. The opening smart quote and closing smart quotes. The generic ones, they're the same. But when you take those smart quotes and you like drag those into a text editor out of a word processor, they'll come in as different characters, but to the naked eye, they'll look at first glance like they're the same, and then you're going to find yourself with weird problems, and that's where they're coming from. All right, and then you just submit your file, your code as a .asm file. Okay, and as I said, it is just a text file with that extension, something .asm. Okay, I'm going to talk about this one now, which really gets more into design, and therefore I probably ought to put it at the bottom.
Can you hear us?
Yes, what?
Hello?
Yeah? Hello?
Oh, I think Caleb Clayson was asking you a question, but I don't think you heard him.
I didn't. No, what's the question?
Okay.
Caleb, oh, hang on a second, hang on. Just a second. Wait. Okay, go, Caleb.
I was just curious on the BR extensions. Do you want us to be able to just say, like, if they do one of those, like BRN or BRZ or whatever, that it just does a BR instruction, or do you want it to just say that's not a and just throw an error?
Yeah, you would still throw an error because the world we're creating here is one in which BR is an acceptable instruction, but like brandy or broham, anything that goes beyond BR is not valid, but that would include BRN, BRP, BRZ, right? So in our little world, we're just ignoring anything outside of BR that starts with BR is not valid. Make sense, Caleb?
Okay, thanks.
Yeah, you bet.
Got it.
Any other questions about any of the other stuff before we kind of get a little bit more into the design? So David said, so Ison, I'm hearing some people, but not everybody. What's the deal? So Ison said, can you hear us, Dr. K? David said, some people have been asking questions.
Yeah, that was a little while ago.
Oh, that was back when I was,
Caleb. Yeah,
that was when I was not hearing Caleb. Okay.
Good. Yeah, thanks.
All right. Good. Okay, let's go. Let's do this thing now. So this is the thing. There are a number of ways to do this little program, okay? I am requiring that you use a state machine. Remember state machines? Remember traffic lights and turnstiles and remember state machines? They were your friends. I told you they were going to come back again and again in your life. Yeah. So you have to use a state machine to do this thing. Now, the other big way to do this thing is basically just as a set of string compares. Where you would kind of just put you'd have a bunch of data, a bunch of string Z's basically, and it would just be like every valid string. So and, right, would be a valid string, and add would be a valid string, and BR and JMP, right? You would just have a whole series of all the valid strings, and then this is what you're not going to do, okay? Then you would just take their string, and essentially what you would do is you would write a string compare function, right? And all the string compare is going to do is look at the first element of the first string in memory, and then look at first element of yours. As long as they stay the same, you're good. And then if you're not, you kick out, try the next. When you get to the end, you're done. That's a valid thing. It's a valid exercise. It's just a different exercise. Okay. What I really want you to do is have the experience of looking at this and viewing this as a state machine. Okay. There's a bunch of reasons for that that I hope you'll trust me on. But it does reinforce the state machine idea, and I think it'll be valuable for you. All right, so it has to be a state machine. So here's the way this works conceptually. I'll read this, and then we'll start drawing some pictures on my vast striped yellow board. If the user types A, now, by the way, I didn't say this. Let me talk about case insensitivity. Let's talk about this one. This is an important thing that you need to think about. Remember that big thing we went through with kind of design and taking a little problem statement, and then what does that imply? What do I have to do about that? Well, I said case insensitivity. Well, what do I have to do about that? Well, I've got a couple ways to deal with this. One is every time they enter a character. Do you remember some homeworks and exams that were all about changing the case of something? You remember that? Where you'd add or subtract, what was it, decimal 32 or hex 20 or whatever, right? To move between an upper and a lowercase ASCII character, right? Of the same capital A, lowercase a, right? The best way, and I kind of recommend this, is every time they enter something, right? Every time they enter a character, you simply take that character and just check to see, you can decide which way you want to work. Let's just say you check to make sure it's an uppercase character. If it's not, then, but it's a valid lowercase character, turn it into an uppercase by subtracting hex 20 from it, right? Then store it away. So they're typing all lowercase, add, but the string you're building is like capital A, capital D, right? So that you just, as they type, and if they typed, capital A, little n, capital D, the A would be okay, you'd put it in. The N, you'd capitalize it, put it in. The D's already capped, put it in. And eventually, you're just creating a string that has nothing but capital letters, no matter whether they typed upper or lowercase. Make sense? And you can do it the other way as well. If you prefer that your program is working with lowercase letters, then whatever they typed, whatever case it is, you just convert it all to lowercase. It would be lowercase AND or lowercase ADD or lowercase JMP or whatever. Okay? That is my recommended way of doing it. Then when you're doing kind of like, working on states, it'll be a little cleaner. The alternative is you just let them dump it in, and as long as it's a valid, upper or lower case, every time. But the problem is every time you have to make a decision, you have to compare it. Like, okay, is this an A? Well, I've got to compare it with uppercase A and lowercase a at that moment every single time. But if I simply just convert it as they type it in, then the string I've got for their input is just an uppercase string. And by the way, if they type anything that isn't alphanumeric, strike that. Alpha, okay, alphabetic. If they type anything that's not a letter A to Z, upper or lower case, you already know that what they typed was wrong. So as you're converting, right, as they type capital A, okay, N, D, ampersand, and as soon as you see the ampersand, you're trying to convert that to uppercase, and you can see that it doesn't fall in the range of upper and lowercase letters. So I already know that this is a failure instruction, right? So I already know that I'm already going, nope, we're done, stop, go to this one spot, and just, let them keep typing, but I stopped processing. I already know it's wrong, okay? And that's another thing I recommend you do is as they're typing and as you're doing that converting, as soon as you can tell that they just typed something that's not even a valid character, because it's a number, right? Or the asterisk or the dollar sign or whatever. As soon as you ought to go to this other routine, this other area of your program where you already know that the answer is false, and you literally just let them type, echo it, let them type, echo it, let them type, echo it. You're doing nothing. And then when they press enter, you say false. You say error. You already know it's an error. But you let them finish, that's all. Okay? So again, you can make your own decision about these things, and almost every code decision has kind of pros and cons. You know what I mean? There's very seldom that there's a code thing that's like absolutely rock solid. One would never ever do this. There's almost always a reason to do most things. Okay, usually comes down to trade-offs of some type. All right. So here's what happens. Let's say they're going to type and. Okay, what's my example here? Yeah, that's the example I used here. They're going to do an and. They're going to type and. They type the A, and I move into the A state, which says I'm in the state in which I have received a single A. That's how I got here. Okay, so I'm going to do it like this. I'm going to start. This is just the initial state. Okay, see it? Okay, that's my start state. And if they type an A, and by the way, I'm just presuming that at this point that everything's uppercase, okay? So if they type the character A, I move to the A state, all right? Now what if they type the letter B? Any guesses? They type the letter B for Bueller, then we would go to the B state. If they typed, what if they typed C? Let me pull up the cheat sheet again, just so we remember what all of them are. Oh, come on. That was such a dumb mistake. Hold on a second. I was just trying to grab the bottom and stretch it. Hang on. All right. Okay. What if they typed C? What do you think? What state should they go to?
Return an immediate error?
They would not return an immediate error because as I said, the user gets to finish typing. But what state would they, my question was, what state would they move to?
It would just be like the fail state.
Yeah, exactly. Like a fail state or a, I'm just going to call it, we'll just call it fail, right? So if they type the letter C, they go to the fail state. Okay, D, fail state, E, fail, F, fail, G, H, I, J, you got to go to a J state because that's real, that's valid. K, fail. L, there's got to be an L state. M, they got to go to the Alameno state. M is a fail state. N is there's an N state. You know what I mean? You get the idea. O is fail. P is fail. Q is valid because there's a quit. We added a quit instruction. S, T, U, V, W, X, Y, Z, all of them. So what you're really doing is you're basically saying, if this thing's an A, go to the A state. If it's a B, go to B. J, L, N, R, S, T, and Q. So in that first, and if it's not one of those, go to the fail state. Okay? So you've got 10 different, on that first keystroke, you can go to one of 10 different states. Okay? 9 of them correspond to the first letter of a valid instruction, and one of them is the fail state. All right? State machines. State machines for the win. All right? And so this represents just, all the other states. Okay, we're at A now. So you're in the A state, and what are the good things that they can say at this point? What's the next character that they type? They type the A, that took you to the A state. What's a good thing they can type?
It's either D or N, right?
Yep. Boy, hang on a second. I botched that one, but okay. Yeah, if you're in the A state and they type D, you go to that says AD. I wrote AN like a doof. Okay, so when you're in the you're in the A state, and they say D, you go to the AD state. You don't go to the D state. Okay, D state was a conceptual other state that you pushed the D first. Okay. And if this is hard to do mirror image, I'm sorry. If they pressed an N, then you go to the AN state. All right? Now, what else? What if they do anything else? Where are they going? Let's say they typed AX. What's that?
Error, fail state.
Yeah, they go to the fail state again. If you're out here and I got an A and then they typed anything else other than a D or an N, anything else, they go to the fail state. So there's a lot of paths to the fail state, okay? Typically there's only 1 or 2 or 3 good things you can do in any given state, and everything else possible kicks you out to the bad state. Okay, let's keep going with AN though, okay? Now, what can you do? What's the good thing you can do?
I have a question.
Yeah.
What if the user types in like ADD and then a space? Should the space make it an error?
Yep. In our little world, yeah. I mean, you know what I mean? You can imagine a situation in which they just get to type stuff and you throw away white space and, you know what I mean? And it would be okay. In our world...
Assembly has no strip function.
That's right. You can write your own. Yeah, there's no like strip out the white space things going on in assembly. But no, you could, that's a matter of spec. We decided as a specification that they were going to type, A and D, and the next thing they typed had better be the enter key or it's wrong. In our little world. But if it were an actual assembly, an assembler, there would be white space before you got to the next token. But we're not going to make you monkey with any of that. Okay, so
Yeah, that makes it way easier.
okay, so what I'm going to do, I'm going to actually use the red pen to show you kind of the path through the state machine that we're following. So they typed the A, which got us into the A state, right? They typed an N right there, which got us into the AN state. They typed a D, it got us into the AND state. Now, what's the only good thing they can do?
Enter.
Correct. I'm running out of real estate here. And what I'm going to do is, hang on a second. So they're in the AND state right here, and they hit enter. Now, by the way, at every one of these spots, let's be clear, like AN, anything else goes to fail right here. Anything else goes to fail, right? Everybody's kicking out to fail. And fails, this fail is just generic. It's just like, eh. You can do fancier fails, right? Like you could have the fail say, look at the string and go, blah, 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 forgats, is not a valid opcode instruction, You can do more fancy or whatever you do on the fail, but it does need to be kind of generic. The specialized fail doesn't even hardly make sense because you don't even know what they meant when they typed what they typed. But so I'm on the end, they press enter, I go to this state, which is, I'm calling it the AND opcode state. That's the part where I output that's kind of a state where I output 001. I spit 001 to the screen. Having done that, I go back right there. Actually, let me use my red again. This is so beautiful. When you're in the AND when you're in the AND opcode, you spit out. This is the output that's going to happen. 0001 spits out to the screen, and then we just go back to this state. We reset and we go back to the very first screen, or the very first state, and clear the string. You know what I mean? We don't care. We start over. We reset everything, and we go again. That's it. That's your program. You can screenshot this. This is conceptual. This is not the code, So first of all, any questions about this, just as a state machine, like what those ideas are? It's the same concepts we talked about when we talked about state machine.
I have a question.
Yeah.
When they finally input their thing, whether it's a fail or an actual thing we can spit out, do you want us to have it loop back to them putting in another instruction, or just that be the end of the program?
So that is right. Let me see. After displaying the output, that's good or bad, your program loops back to the top, reinitializes anything that needs to be reinitialized, and goes again. And you don't quit until they type quit, you don't quit. which means also there has to be a Q state, a QU state, a QUI state, and when you get to the QUIT state, if the next character is a return character, then you just jump to the halt instruction and stop. Make sense, Caleb?
Yep. Got it.
Question.
Yeah.
So you said there's two ways of doing it. When like you process it as the characters are inputted versus like when you hit the enter key and then you just process it. Does that mean that you don't, in the instance that you're not processing stuff until you hit the enter key, then that's when you do all the state work versus doing all the stuff during the process?
Yeah, let's put it this way. If the same state machine still applies, in one case, it would be like they pressed the A and we moved to the A state in our code. Now, in the A state, I would literally have to I'd have to get their input now. A state would have to read a character from right here. See what I mean? And then I'd read it and it would go, oh, it's an N. I would move to the AN state, and now in the AN state, the code in this state would have to read a character. See what I mean?
Yeah, I see.
Alternatively, they're typing and we're just putting it all into, a string, right? We've just allocated some space with like a block word, right? Like a dot block W. And then they're like, actually what I want to do is like that, right? So we have in this string now, they typed an A, we put it in there. They got an N, we put it there. The D, we put it. The Y, they said Andy. And then they finished and we put a 0. Okay? That is a Mungie 0, right? Now what we're going to do is we don't have to embed the reading of characters, inside the state machine. But what we do have to do is in the start position, have some kind of a pointer. And when we look at that first character and we're like, hey, that's an A, we're going to go to the A state, right? Then the pointer's like coming along with us. The pointer's now here. What's the pointer say? N? Okay, we go to the AN state. And the pointer advances. What's the pointer? It's a D. Okay, we go to the A and D state. Pointer advances. Y? Fail. So, again, you can see kind of how either one works. I don't even really feel like that one is stronger than the other. You know what I mean? I don't have any real sense of that. For whatever reason, I like to enter their input into a string. I like that. And that's just personal. I think most people do it that way, but maybe it's because I say that I like it. So I don't know if there's like a bias, you know what I mean, that I'm imposing on you. Okay. What questions? What's nagging you? What's kicking your butt right now as we look at this and, think about this? In
My
fact,
brain's stuck in another module, so I'm having trouble absorbing.
okay. Also, would it be beneficial? Should I get a closer shot of this and drop it in the chat? Is that helpful? It's screenshot. You can screenshot it, obviously, real readily, from the YouTube stream.
Yeah, I think that, anybody can just pause the YouTube stream and then just look at it from there. So it should be fine.
Seems like it to me. But, happy to create an artifact. And even this is just like one instance of, I've drawn this picture many, many ways at different times. Okay. Let me see. What if they use more characters than the space we allocated? David, great question. Here's my recommendation. My recommendation is, back in the day, there was kind of a classic. There was a classic idea that everything was like 80 characters, because I think that was the width of a standard original IBM monitor, or maybe it was the width of a teletype. I don't even know, right? But that was kind of a standard thing. So one approach is you just allocate 80 spaces. The other approach that Stephanie brings out is, one approach is you allocate 5 spots, right, in the string. I mean, what's the longest instruction? Trap? Textually. How many, what do we have that are 4? Oh, JSRR and trap are the 2 that are 4 characters. And by the way, yes, JSR and JSRR are both valid. They both produce the same opcode too. And once you're at JSR, you don't know that you're done yet, because they could either press an enter key, which would be good, or the R, which would also be good, which would then, you know what I mean? Then you'd have to still go and enter. And ironically, they would still both produce the same opcode, but you know what I mean? The layouts are different and the instructions look different, but the opcodes are the same. Yeah. So what? And quit. Thank you, Stephanie. That's right. Quit is actually the other one. So what you would have to do, though, if you were doing Stephanie's thing, as soon as you got to, like, when they typed the 5th character, right? When they typed the 5th character, you could just jump to the fail state, right? Or to the let them type their little happiness state. Right, you jump to the state that just lets them keep typing until they say enter, and right, that would be reasonable. And yeah, Jay, there is not really an exit and a quit instruction in the cheat sheet. We are saying we're going to make our own quit, which is just, if you say quit, that's when the program quits. But there's not an LC3 instruction called quit. Correct. But anyway, I mean, it all depends on what you find most clean, right? And you could even do, we're trying to make this as simple as we can. So for example, it's totally fair if you decided that 10 characters was the size of your buffer, and you put a little thing like, please enter LC3 instructions, and even said like max 10 characters, you know, or even max 5 or max 4, you know. That's one approach, is max 4 characters, so that the person doesn't think that they can go blah, 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 you know. Because if somebody says there's 80 characters and you type 81, you're spilling over into other stuff that might be there, other instructions. No, so quit. So David, I think you may have misspoken. No, we're not doing any of the assembler directives. So there's no .org, there's no .block w, .string z, .fill, .end. Yeah, there's none of those. You don't have to worry about any of those. You only have to work, because they don't have opcodes. Those are directives to the assembler. And quit, you do have to have quit, but we made that up. That's our little instruction to the program and not part of the LC3. Cool. Okay, what else is nagging at you? What's nagging? The other thing we can do later on, maybe even week of Thanksgiving, I don't know, is a little help section where we can, you know, answer more detailed questions, get on the LC3 simulator, you know, play around with different things. Some of this is stuff we're going to get to in the lectures, you know, right after Thanksgiving. Jay, any text editor that is a text editor and not a word processor. So no to Word, no to OpenOffice, no to anything that is not a pure plain text editor. So Notepad.
VF Code.
What's that?
VS Code, Visual
I-
Studio Code.
Yeah, I'm sure that's fine.
Just so you guys all
I haven't
know,
used it.
VS Code does have an LC3 extension that will do like syntax highlighting and.
Oh,
it'll
really,
do-
Zach?
Yeah, it'll highlight the syntax and even like if you type add, it'll like set up the whole add instruction for you in assembly.
In VS Visual Studio.
Yeah.
Nice.
Code.
Nice. Yeah, let me take a look. Wait, who's tempting Dr. K, Jay? Andrew or Zach? I'm not tempted to Visual Studio, just so we're all clear. I'm just looking at what Andrew did there. Oh, Andrew. Yeah, I'm just kind of checking it out. You'd have to like look at it and understand the notation, right? You know, A goes to N and D. Yeah, I mean that's helpful probably. That's not complete, of course. Is it? I don't think so. Thought it was. It might be. Let me see. Yeah, I think maybe it is. Yeah, the only problem. No, I think it. Sorry, I'm just trying to. Yeah, I think it might be. But again, to use that, you've got to also understand what you're doing. You know what I mean? Because the notation is terse. You'd have to get your head around the notation and kind of how to read that. But if it's helpful, I think that's great. And thanks for sharing that, Andrew. Because really all you're doing is sort of condensing what's in the in the cheat sheet, right? Let me see. Another couple of things. We only have a few minutes. Things I want to say. Build it modularly. And what I mean by that is do not, for the love of all we hold sacred, do not sit down and write this program start to finish in a text editor and then drop it into your LC3 simulator and then spend the next 300 hours trying to debug it. Do not, don't.
Debug as you go.
Debug as you go, right? So you like, okay, first thing, I want a little message that goes, hey, everybody, right? I want to just go, hey, welcome to my cool program. Please enter your whatever. So I'm going to go to the LC3, right? And I'm going to write. Yeah.
I just have a helpful mention, I guess, for anybody that, is feeling flabbergasted with the project or anything like that.
Yeah.
What I've noticed is that if you break the the sections or the project down into small chunks, little by little, then the whole project becomes easier over time instead of waiting till the last day and then, writing it all out at once. I think it's helpful to do small chunks at a time. That way you can not overwhelm yourself when the time draws near and you don't have to worry about the fear of God speech as you proclaim all the time.
Yeah. No, that's right. And that really reiterates what I was saying, right? So pick a thing. So I'm just kind of playing around right now, right? Like, how do I make a message? Well, I already know there's a thing called string Z, and I can be like, enter your LC3 instruction, right? So I can do something like that. And then what I have to do is go look up. You know that I do all my I/O with trap stuff, with trap instructions, right? So then, I just want to just illustrate how you can take it a piece at a time, and then you don't have to freak out. It's that same thing we were talking about that when we talked about design, right? You don't have to do the whole thing, eat the whole thing, okay? You look at it, it's all open book. It's a finite search space. So like put S, write a string of ASCII characters to the console display. Characters are contained in consecutive memory, 1 character per memory location, starting with the address specified in R0, and it goes until there's a 0 in the memory. Okay? So, what's my instruction? First of all, I've got to get the address, right, of that string. I made a string with the .string_z assembler directive. And in fact, let's just do this. Assemble, load into simulator. Okay? I want you to just see what we just did, right? There's our halt instruction, and here's the string. And if you look this up in the ASCII table, it would say, whatever I just put in there, please type your blah, blah, blah. That's a space. And then another space. And somewhere down here, it's going to stop with a 0. There we go. That's when that string ends. Okay. So, stop. Right? Enter your LC3 instruction. So we actually manually inspected it, and that told us that, that it was correct. Now let's try to spit the thing out. To spit it out, we got to get that address into R0 and then call, what trap instruction was it? Trap 22. Or we can just simply say put S. How do you get that instruction into the intro? Sorry. That instruction that's labeled by intro, that address, into R0. What say you? You know it's a load instruction.
LEA, load effective address. Is that it?
I believe that's correct. Now in assembly language, we're not looking that up straight up, but if I go, sorry, I said LD because I'm a doof, LEA, and then it wants the destination register, which is going to be R0, and that should do the trick. Now here's what we can do to test that. Load that into the simulator, and then go next. Sorry. We already know that 3002 is where that string starts, right? I go next. You see it? We just tested it. We added one instruction, and we tested it, and we know that that works. Okay? That's kind of cool. Let's go back. Now we're actually ready. Now that we've got our 0, we can just go put S. Right? Which is, we can also say trap 21, but we can also say put S. We assemble, we load into the simulator. Okay, let's go load the instruction. Actually, let me reset all the registers. And now I'm going to go next. Boom, do you see it? And then we just stop. And so, do you see what we're doing here? Let me get that all reset. I can also clear the output. But check it out. We have a program. We said where to put it. We built a string. So literally this is like a 3 instruction program. And we did like 4 or 5 tests to get to this part. But here's the key, and this is what's so important. We're out of time. But this is what's so critical. At this point, does everybody watching that has a pulse and has been awake for this, does everybody actually know that this works? That this is correct? The answer is yes. Yes. Because you know what LEA does. We looked it up. We ran the test. You can see the string in memory. You see what its address is. You see that address show up into R0. You called put S, and the string appeared on the screen. You know it's correct. Okay? You know it's correct. And if I run it, that's all it does. Now when I'm ready, now I keep going. Okay, the put S works, you know? And then I can do something like, I can start doing, I can start dropping comments to myself, right? And then it's like, you see what I mean? The comments help me with conceptual, like that's the intro message right there. Okay? And then whatever I do next is maybe when I start to input from the user. Now I've got to like, now how do I do this next part? Right? Does that make sense? You just got to take it one little chunk, do the next thing, and then look it up every time. Don't play guesswork. Don't be like, what about a, and then just see. That's just a recipe for disaster and you'll never finish. Okay? So here's the thing. It's bigger. The project is bigger. Like I said, it's probably around 500 characters. 500 instructions. When you're done, a lot of it will be duplicate stuff. It'll start to look the same, but the patterns will begin to be kind of clear to you. Okay, we're out of time. We got to stop. Yeah.
590 lines.
What's that, Zach?
Mine only got to like 590 lines.
Mine was in that neck of the woods.
It was repetition, so.
Yeah, that's right. A lot of it was
Most
repetition.
Of the states are like the exact same thing, just different checks running.
Huh. Mine was around 300.
Did you do it with a wait? Who said that? Vlad?
Yeah.
You did it with a state machine. You didn't like cop out and go string compare.
Honestly, can't remember.
Right.
It makes it take a lot more lines.
Yeah.
String compare is straightforward.
Okay, I got to go back and look up Vlad's program now. 300
yeah,
lines.
Might have
I think he's.
I'm glad you might not have an A after all.
I'm gonna retroactively pull Vlad's A. Is what I'm gonna do.
300 lines. I'm really curious to see how the hell you did that.
I am curious as well. We're now, Vlad. You're under suspicion. You need to know that.
Okay.
We'll go look it up. All right, man. So, all right, we're done. We're good. We're stopped. Do we need some take us out music? Do we have any recommendations from anybody other than Zach? No, I
I have the same taste as you.
I know. No, I got it. Here we go.
Hey, yeah, there we go.
This is motivational right here. This is "Let's Go," right, by the Cars.
The Cars.
The Cars. Yeah. All right. Enjoy, everybody.